today about how to debug Salt. And I'm kind of go through kind of what I personally use, and so hopefully it's a little useful to some of you guys. And I've got a couple of engineers in the back that are going to help answer questions. They didn't know that they were, but they are going to. All right. So my name's Megan. You can also call me Shell. No, it's not short for Michelle. It's a very nerdy video game reference. So, and if you know the video game reference, I don't have anything to give you, but I'll give you mad props. All right, and yeah, if you've ever seen me on GitHub, I help triage some of the issues. So you'll see my name there as Shell, and I think that's even the picture I use. So awesome. Let's just get right into it. So my talk's going to focus mostly on the standard master to minion communication, and so I'm not going to go dive into anything else, but you're welcome to ask questions about other things. So there was a great talk right before this, and it talked about the architecture of a job flow. So I don't want to go too much into what that job flow looks like, but I'm going to go over it a little bit and kind of emphasize some of the points where things would be actually useful in terms of troubleshooting. So there's a couple of Salt master processes that are used within the Salt master. There's the publisher, and this is on 4505. I'm sure you guys are familiar with 4505 and 4506 because you got to open up the firewall for that. And it's got to have an established connection to the minion, and the purpose of the publisher is it's going to actually publish commands over whatever transport you're going to be using to the minions. So that's the publisher. Then you have the event publisher. This is going to publish events on the event bus. And you're going to hear a lot about the event bus, I'm sure, within Salt, because we use it a lot internally within Salt's intercommunication. And then we have the M worker. And the M worker is going to manage a lot of the back-end operations of Salt Master. And you'll see, we'll talk a little bit more about exactly what it's doing and why this is important in terms of troubleshooting. And then we've got the rec server. It's on that infamous 4506 port. It also needs an established connection to the minion on whatever transport you're using, and it has a couple of roles. It's going to be able to take requests for jobs and distribute them to minions, and it's going to actually also receive replies back from the minions. So a couple of important processes. One little cool thing I found out is within Salt's code, we use this little Python module called setProcTitle. And the reason that's awesome is if you install that Python module, you'll actually be able to see which processes are each of these Salt master processes. So let me show you that really quick. Tell me when to stop. Okay. All right, so I'm just going to be using the daemonized process of the master and the minions, so not using systemd or anything like that, so a little unconventional. So I'm going to start up the Salt master, and before I do that, I'll show you I actually have that module installed. And if I do let me zoom out, you can actually see which of those processes is one of those processes we just talked about. There's a couple more here that we didn't go over, but we're not going to go over those for the purpose of this talk, but we can then see, oh, this is the pub server, and we're using 0MQ, so it's called 0MQ. We've got the event publisher. This is another process we're not quite going to go over, but it does a lot of maintenance within Salt. Then we got the rec server, and then we have the M worker queue, and we've got 5 M workers, 0 through 4. And by default, there's going to be 5 M workers within Salt, but that's a number you can adjust. And we'll talk a little bit later about why and when you would want to adjust this. Cool. So just a neat little tool. You can use it in terms of maybe one of those processes is taking up a lot of the CPU power on the machine, things like that, and you're going to know exactly which process within the job flow is actually hindering this. All right, cool. So now to just kind of see this workflow a little bit, I got this graph right here. It might be a little bit hard for you guys to see that. Let me see if I can pull it up in GIMP and increase it a little bit. All right. Is that a little bit easier to see? Okay, cool. All right, so you start on the CLI, and you type salt, and then we target whatever machines we want to target, and then or in this example, we're just going to run a test.ping, just a typical execution module. So one thing to note with the Salt CLI tools, they just really are wrappers to APIs. And in this instance, our API is local client. So what local client's going to do, it's going to get that, and it's going to grab that request for the job, and it's going to send it to the request server. The request server then gets it, and the job for the request server is defined whatever available M worker there is, and it's going to send the job to that M worker right over here. Now, the M worker does quite a bit of things in the backend operations, so the first thing it's going to do is it's going to make sure, can this person actually even authenticate? Can you run the commands? And then it's going to do another thing. It's going to send an event to the event publisher, and then the event publisher will publish that to the event bus, saying, hey, I'm going to be publishing this command. And then the event publisher will publish it to the event bus where anything that's listening to it can interact with it. All right, so the M worker does those couple things, and then we're going to send it to the publisher. And what does the publisher do? It's going to publish it to the minions. One important thing to note is it's going to publish it to all minions, and then once it gets on the minion's going to determine whether it should run. So let's zoom down. So now we've got it on the minion. The minion sees the job. It's going to determine if it's going to actually run the job, and then it's going to start up a new process, and it's going to run the job. It's going to run the execution module on the minion. That's an important note. And then it's going to send the job results back to the request server. The request server, once again, it just tries to find an M worker. It sends it to the most available M worker, and then the M worker simply decrypts it, sends an event again to the event bus saying, the job is done. The job's done. The local client is actually listening to the master event bus, sees that event, and spits it out to the CLI. So that's kind of a quick overflow. Like I said, there's more to it, but I don't want to go into too much detail, but there's a couple things I want to focus on in terms of troubleshooting. One thing is the process of the request server to the worker threads. You can imagine when you start getting a lot of minions and you're getting a lot of requests coming back at the same time, that the request server might have a little bit of a hard time handling that. And so, because it's blocked until it can send it to a worker. So that is one thing in terms of troubleshooting that you might have to adjust to optimize your infrastructure, is adjust that worker threads, and it's just a configuration within the master config file. And but for most people, you're really not going to need to adjust that. 5 seems to be right where it needs to be, and it depends on what's on your box in terms of power and memory and things like that. Another thing I want you to focus on is the event bus. The event bus is used a lot within the Salt Master. And also I didn't note, but there is an event bus also on the minion as well. And it does the same thing. It reports to the event bus when the job is complete and things like that. So those are some things that you can monitor. And I'll show you here in a second how you can monitor that and interact with it, and why it would be useful when troubleshooting. So those are a couple of things I think that are important in terms of troubleshooting. Another thing is to note, as you can see within this, Salt is very asynchronous, and so that kind of creates problems when troubleshooting sometimes. So I'm going to give you some ways that possibly can help hinder or can help with that process. All right, cool. So we know how the job flow works, so let's go to troubleshooting. What can we do? We're running into issues. Where do we look, etc. So first of all, let's focus on the Salt Master. I know, it might be lame to just say look at the debug logs, but I think it's important to note that you're going to be able to see a lot of things that we just talked about within the debug logs in terms of events going off and all of these processes intercommunicating. So I wanted to show you that really quick and what you can be looking for, because when I first started with Salt, I kind of just ignored a lot of those, but when you really take the time to understand what's going on, it can help you in terms of troubleshooting. So I am going to show you a couple ways to interact with the debug logs, and hopefully that's useful to you. All right, one way is you can actually run the Salt master in the foreground. And so that's simply like this. So this will just start the master up. And we're going to see a bunch of stuff here. And I just want to point out a couple things that are going to start looking familiar to you now that you understand the job flow. You're going to see things like we're starting the publisher process. We're starting the Salt publisher on 4505. We're also using a lot of the IPC within the intercommunications in Salt. And so you can kind of see where things like this would start being useful to understand what processes you need within this environment. Also, let's go ahead and run a job and see what sort of information we can glean from there. So I'm just going to, start the minion in the background. And we're just going to run a test.ping. We'll just keep with that example. Keep it simple. Okay, so running the command, we get a return true. Let's go look and see what's actually within the log files. All right, so there was some data cache going on here. So let me do this really good so I don't have to find where we are. Okay, cool. So first of all, one thing I didn't mention is we actually have to get the JIT of the job. So you can see that happening there. And then we can see the IPC communications for the event poll happening, because it's a publish and poll process. We can see the event tag and information occurring here. We can see that we then see that there's going to be a new job that's going to be run. Just like we said, we're telling the master event bus that we're going to be running this new job, and here's all the information. We're running test.ping. These are the minions that we're going to be targeting, and etc. We can see other things like the root user published this command. And then there's some encryption also going on here. And we can see here, finally, we got a return from the job, and once again, we're going to see that event. So you can see why the debug logs are going to be useful in terms of what you should expect in terms of the event being published, telling it that the job's going to start, and expecting that job return on the event bus as well. So debug logs, another way to interact with debug logs is to actually set it within your master config file. And there's two arguments that you'll want to be familiar with. There's log level and there's log level log file. So there is a difference between the two. Log level is going to determine what level of logging you're going to see on the console. And log level log file is going to determine what sort of logging you're going to see in the log file. So let me show you really quick what you would expect to see on the console. Start with the Salt master. I didn't think that might not work because I just started the master. The minion might need to catch up. Okay, cool. So yeah, as you can see, you're going to get the debug information to the console. Simple, but it can also be really useful. But you're also not getting all of the debug information for all the other things going on in the master. It's just specific to the job. So kind of a nice way to interact with debug logs. And then this one's pretty self-explanatory. It's essentially just going to give you the debug logs in var log salt master. So, and it would look just the same as if you ran it in the foreground. All right, cool. So we got the debug logs. We can kind of see what's going on. But what's this master event bus everybody keeps talking about, and how can I see it? So there is a runner that you can use to interact with the master event bus and see what events are going across. So why is this useful? It's because within Salt we use events a ton. We can actually go look in the code here. Let's see here. And you can just grep for fire event, and you can see, let me remove the test directory. And you can see that within Salt, we're firing these events throughout the code. And so you can look and grep through these and see where you would expect an event to be fired within the code. And you can see if you see that event on the master event bus. Also, we have some documentation on some events that you might see that are expected within Salt. So we can see here, we would see a event with the tag salt auth anytime there's some sort of authentication request from the minion. We've got an event when the minion starts. We've got key events, anything related to the salt key. And then you guys saw these. This is the new job tag. We also have a job return. And then if a job is taking a while, we've got the progress tag. You'll also see the similar events when using a runner. And we have these present events, which is not on by default. It's something you can use to detect if a minion is connected, and that's something you'd have to set. And then you can also see within Salt Cloud, we use it tremendously. There's a ton of tags there. So if we go into the code and dive in, you can tell pretty quickly what it's trying to do. So let's go look at key.py. So if we just search for fire event, we can see here pretty quickly that, oh, okay, this is probably going to fire an event anytime a key is accepted, just looking at the load here. This is also accepted, but if you look at the function, it's accept all. We're going to see one when the key's deleted, and et cetera. So grasping through the code and understanding when you would expect to see an event, if you're not seeing that event, obviously something's going on. So how can we see these events? One way is there is a runner. So run state of event, pretty equals true. You don't have to use pretty equals true, it just obviously makes it pretty. All right, so we start that up. And let's run our test.ping once again. Cool. So now we can see all the events that happen here, and it's outputted nicely for us. We can see the JID, we can see there was a request for a new job, and then we can see we got the return for the job. And like I said, you're gonna see these events all throughout in the internals of Salt. Sometimes this can get a little messy, and sometimes I'm only looking for a particular event. And so it's actually really easy to listen to this master event bus. So I've got an example here I want to show you guys. All right, cool. So pretty easy. Just a couple things you need to do to listen to that event bus. First, we're going to create our event object. We're going to tell it we're looking for the master event bus, and then we're going to just do a while loop that just continuously goes, and we essentially just run get underscore event, and that's going to get all the events on the master event bus. Like I said, there is a way to, and then using this approach, we can then filter the events so that we can only see what we're actually interested in. So there's a lot of power here that you can use in terms of troubleshooting. So I'll use this a lot if I don't want to have to scroll up through the event logs. So I'll show you guys this really quick. All right, so it's got that while loop going. I'm going to exit out of that one. And we're going to run test.ping. And instead of seeing all the events, we were matching on just returning the job arguments for the return. Another thing to note is you can actually initiate an event from the minion to the master to, for example, to test communication that way. And so let me show you. We can also do the same sort of thing, just match on that tag. And let me grab that command so I don't have to type it out. So this is simply going from the minion to the master, Event.send is the execution module. We're going to give it the tag, and then we're going to give it the data that we're going to send on the bus. So let me start up this again. Make sure, yep, so as you can see here, we're matching on that specific tag, and it's going to do the same thing. We're going to be able to only view that event. And we're also testing whether we can actually send events from the minion to the master. All right, cool. Got the return, and once again, we see the tag and the data that we sent through. So just kind of a nice little utility that I've used to filter out the output. All right, cool. So that's the Salt master. So let's talk a little bit about troubleshooting the Salt minion. You can do a lot of the same things as you can do with the master. You can run the debug logs in the foreground. You can use the log level arguments within the minion file to configure how you're going to parse those debug logs and how you're going to see them. One important thing that I use all the time when troubleshooting master to minion communication or execution modules or state module runs is using SaltCall. It took me a while when I first started with Salt to understand where I would see the information that I wanted to. And so it's important to understand where things are occurring everywhere within Salt. So knowing that pillars are rendered on the master, you're going to see pillars within the master debug log. Knowing that the execution module is going to be executed on the minion, you're obviously going to see a lot more information on the minion log. And salt call is going to initiate the call from the minion, and it's going to run that execution module or state module, whatever you pass it, and you're going to see all that information if you pass -l debug, and it's going to be really useful. So I want to show you an example of that. Man, go over here. All right, so for example, let's just do a package install, but the package doesn't exist. Sorry. But let's pass debug, so we're seeing the debug information. All right, so we're seeing a couple of things here. We're seeing that we're seeing the GID number here. We should see the return soon, but what we're not going to see is why, possibly what commands the package.install is running, etc. So obviously that's going to return and tell us that it's not able to install that, so I'm going to close that. And I just want to show you the comparison with these calls. So you can either use saltcall and run the command, or you can use saltcall --local. --local just won't reach out to the master for things like whether there's files that need to be re-downloaded, things like that, update pillar information. So for this instance, we'll just use saltcall, package.install, does not exist, debug. So you'll see here really quick that you're going to see a lot more things. You're going to see, oh, wow, okay, so we're running an RPM command, probably checking to see if the package is already installed. We're searching for repos in here, and then it looks like we're going through the repositories and checking to see if the package actually exists. So as you can see quickly here, this is going to give you a lot more information when troubleshooting things that are not working when running commands against the minion. So saltcall is definitely your best friend. All right, cool. All right, my computer just crashed. Awesome. We'll give that a second. Maybe it'll come back. All right, so trying to think. Just one second. Yeah. Right. What I would do is just run command.run and then salt-call the command. Okay, yeah. So he's asking if how can you get that output from the master? What I would do is I would just run command.run and then pass that command to it, salt-call and -l debug, and you should get the input or the output. Oh, yes, it came back. Patience is a virtue. All right. All right, cool. So as you can see, we got the error telling it does not exist, obviously, but just wanted to show you the output that you're going to get and how much more useful it might be when troubleshooting. Okay, cool. One thing I wanted to show you guys, and maybe it might not be as useful, but it is for me, and I use it on a daily basis, is a Python debugger. This is going to require getting into the code a little bit and understanding, like I said, once again, where do things actually run. And so there's a lot of Python debuggers out there, but I was just going to show you guys kind of what I've used in the past. But just know there's a lot more options out there. I know a lot of people love the PyCharm debugger, and it gives you also the ability to remotely debug as well. I hear really good things about it. My favorite debugger is PudB. And I'll show you guys that here in a second. So let's show that off. All right. So one quick thing to know is within Salt's directory, you have a couple folders that you might want to be familiar with, modules and states. And pretty self-explanatory. States are going to be state modules, and modules is going to be execution modules. So just knowing where to edit the commands. So let's just do a quick example here. Just using that same test.ping example, we're just going to simply set a trace point. And in PudB, you simply import the module in pu.db. And we're going to initiate the debugger here within the ping code, the ping function. So let's edit the code a little bit and let's see. All right, so obviously that's going to return false, but let's say we don't know it's going to. It's very magic. All right. So let me show you. So if we were to run this command like this, it's not going to work because, as I stated, the execution module is going to actually run on the actual master, and we're initiating this from the master and not the minion. So, okay, yeah, that didn't work. Just 1 second. Just do that over again. Whoops. All right, anybody see what I'm doing wrong? I do, yeah, this is my example I'm trying to show, but I was expecting a different error. Could be, yeah. Let me just try it without the debugger. No, I have my, no, I don't need to sync it. Okay. So, let me check. This actually might be the error. Just 1 second. Okay, yeah. That actually is the error. My apologies. I was looking at the, I was too focused on the past invalid arguments. So you'll see something similar to this. That's what I was looking for, and it was staring me right in the face. And the reason it's not going to work is because the debugger is initiating on the minion side, but you're on the master side. So like the gentleman said over here, the best way to approach this is to run salt call, because then it's going to initiate it from the minion, and it's going to, you're going to see the debugger. All right, cool. So this is PudB. I like it a little better than PDB, but it's not in the Python standard library, so you'll have to install it. It's an additional module to install, but you got a couple of pretty things here. You can interact with the code here. We can see the variables over here. We can also look within the stack and see how we got there. And you can also set breakpoints just like you can in any debugger. This is just my preference. We can also interact within the debugger. We can do things like just print a value. So we're like, okay, before we run that code, what is What are we expecting to return? Okay, salt utils is proxy, false. So debuggers are really useful in terms of getting into the code and really understanding what's going on there. So to interact with it, we're just going to hit N for the next line. Then you can see here we're adding a log to the log file, and we can see here the issue of the problem, right? Oh, we're returning false. That obviously needs to be true because there's no reason for it to return false there. So what is a way that you can handle it so you don't have to log on to your Salt minion each time? And the answer is using a remote debugger. Let me show you an example of that. There, like I said, PyCharm supposedly has a great remote debugger. I'm just going to show off remote PDB so you guys can kind of understand where you would use it. Okay. Sorry. I see. Okay. Oops. So for the remote debugger, we're going to specify what port we're going to be using. And so what's going to happen is we can now initiate the command from the salt master, and then we're going to use telnet to go onto the port 4444, and then we're going to get a PDB debugger, and we'll be able to debug the code that way. So in the same, I made the change in, good question, he asked, where did you make the change? And I made it in test.py, which would be on the minion. Yeah, you would need to edit on the minion. If you edit it on the master, you would just never see the debugger even try to come up, unless you were in it communicating with the minion on the master. Okay, so as you can see, it's just waiting because the debugger is up and running. So now let's now we have a PDB debugger. So as you can see, PDB is not as fully feature-fledged as PUDB, but it's going to give you enough. You can hit H to interact with it, and you're going to get a lot of ways to interact with your code as well. So a couple of ways to interact with the code. Another thing to mention is you can just add print statements within your code, or you can use the salt's logger, and pretty easy. It's just log.error, log.debug, and so forth. Eric? PUDB does? Oh, I looked it up. There was like an issue and it wasn't resolved. Sweet, okay. I guess PUDB has a remote debugger. Okay, cool. Awesome. All right, so does anybody have questions about that before I continue? Or anything that I've spoke about? All right, cool. Let's see here. All right, so one other thing that I just wanted to go over in terms of troubleshooting is the state system within Salt. Personally, when I started Salt, it was really hard to kind of understand this system, and so it took a lot of just sitting down and understanding how the internals worked to help really troubleshoot when things went wrong when trying to render a state file. So there's two concepts that are useful to understand when it comes to rendering a state.sls file. And the two terms is high data, and high data is usually what the user's going to see, and essentially it's just a large Python dictionary. And we can see this high data by running state.show high state. So let me show you that real quick. And let me show you the state file so you have an understanding of what we're trying to run. So that's our top file, and we're going to be running the package.sls file. So pretty simple. It's going to install htop, and we're just going to add a blank file called temp test. Okay, cool. So now we can see the data, and what's even more useful is to use something like a JSON outputter so you can see the type of data that you're going to be getting here. And so that's high data. And then we have the concept of low data, and this is what Salt is going to use to ingest internally by Salt. It's just an order list of single state calls that the minion is going to execute. And we can also see that, oops. By doing the following. So you can see the structure has changed a little bit here. So it's just, we've got the minion ID here, we've got name, we got the state, the ID, what's the function of the state we're going to be running, and we've got these orders. So why is this important to understand? I think it's important to understand if you, when trying to possibly using a new renderer or even using the YAML renderer, because as long as you use the same data structure across the renderers and it compiles to the same data structure, you're going to be fine. And I'll show you how you would use that within YAML. So using that knowledge, it's important to understand a couple of things about YAML. One, spaces versus tabs. Always use spaces within YAML. But one thing that helped my understanding is understanding within YAML what a dictionary is and what a list is. So if we pull up a YAML parser online, I'll be able to show you this pretty easily. So, can you guys see that okay? Okay. All right, so let's write up a module here. Let's just say test state. We're going to run a command.run, and the name is echo test. Okay, so now we can see here in JSON what kind of data structure we're getting here. So one thing to note with YAML, anytime you see a colon, it's going to be a dictionary. Anytime you see a dash, it's going to be a list. So if we look here, we're going to be expecting this to be a dictionary, this to be a dictionary with a list inside of it. And if we look over here, we're going to be able to see that as well. So as long as you understand what the data structure needs to be, you can use multiple renderers, or you can go in here and make sure that your state files are going to run by pasting it in here and making sure that it's parsing correctly. All right, cool. One other thing to note that helped me a lot is there is a Salt Vim plugin that you can use, and this helps in terms of giving you syntax highlighting and giving you the spacing that you need. Really helps just eliminate any errors that you might run into when rendering your state files. Another one I wanted to focus on was Jinja, because it's the default templating language within Salt. There's a bunch of Jinja docs that I would highly recommend within Salt, and I've added them to my resource slide here. But there's some caveats that you might want to understand with Jinja. Also, once again, the Salt Vim plugin is going to help you with that. One thing that really helped me within Jinja is this show full context. So let me show you an example of that before explaining it. All right, so we're just going to, right here, we're just going to log an error, and we're going to run show full context. And that's going to show the entire context that we're going to have available within our Jinja. So if we run this, we can then see this massive dictionary here, but this will be able to tell you what's in your context. So if you ever get a common error saying the Jinja, that it doesn't exist, this is one way to see what you might have access to within Jinja's context. So just a little tidbit. And also, as you can see here, you can also log within your Jinja as well to help debug your Jinja files or your Jinja syntax. That's all I had. These are my resources for a couple of the things I talked about in terms of YAML and Jinja. Is there any questions? Yeah, you over there. Yep. This or on? Yeah. Yep. All right, any other questions? Yep.
I run into issues where I have a file that's templated with images, and before I actually want to run that state or that salt ID, I want to see how that file will actually render within the context of its salt environment. Is there a way to do that?
Yeah.
Like testing it through for a high state, I just want to specifically target that.
Right. So his question is, what's one way to possibly see an entire SLS file being rendered? I'd really recommend state.show_SLS. Yeah.
There's also a module called SLS info.render, where you can just render any file.
Yep. Cool. All right. Anybody else? I saw a couple hands over. Yep.
I don't know if this is the setting. It used to be on our Windows minions that during a small call they actually see in real time from the execution of each individual state. Is that configurable, or is that a feature that got deprecated, or how do I get back to that?
Maybe I don't quite understand, but I like you should already within SaltCall see everything that's going on. So.
What I mean is during the execution, like we had a high state that would run for like half an hour.
Uh-huh.
And so like during that, you would see the success. You know, you could just kind of pop open the SaltCall and see where it was in the high state because it was just recording back one at a time as opposed to waiting for the entire job to finish.
Are you talking about from the master you're seeing this information? I don't know. Do any of the engineers back there know? Yeah, you should be able to see everything. So, yeah. Yeah, maybe that's what you were using. Yeah. Anybody else? Yeah. Yeah, I was going to do that after this talk. Yep. He asked if I was going to post the slides to that. Yep.
So there are also wonderful Emacs modes for Inzip and salt state and YAML editing.
All right, I hear some snickers here. I'm just joking. Right. No, yeah, that's a good note. There's a lot of he mentioned that Emacs has a lot of like great, I assume, syntax highlighting and things like that for Jinja and YAML. And I'm sure any sort of text editor that you're using is applicable. I'm sure Sublime Text has something, and I know probably PyCharm. So that's good to know. Yep.
Sorry, it sounds like my last question. If you have a long-running state of any kind, you want, I know you can do it without running, and it will show you the job name, but it won't really show you detailed what active state is running. Is there any way to get that kind of information on a job that's currently running?
From the master?
Either way.
Yeah, like I said, my only idea would be you want to see like the exact commands running?
Yeah, like it's stuck on something for a long time, I just want to know which one it is.
Right. Yeah, for me it would just be debug logs, right? That's the only way I know.
But if I didn't start with debug, there's no way to check into that.
Not to see what's exactly running. Yeah. Over here. All right, there's one more gentleman over here. Yeah. I can't hear you really well, but I heard something about progress event. Yeah. Yeah. It would be for long-running jobs when when we're checking for the progress of the job. Is that your question? Oh, no. Like what command it's running? Is that your question? Okay, yeah. No, it'd just show you that it's checking the progress of it, making sure it's still live and running. Yeah. All right. If you have any other questions, feel welcome to come up. So, all right, thanks.